Stan Gibilisco here, proprietor and operator of amateur radio station W1 GV Whiskey 1 Good Vibrations at your service to describe my perception of how a small transmitting loop antenna works. Now, a few manufacturers make these things, and by small, what I mean to say is a tenth of a wavelength in circumference or less. So that, for example, on 14 megahertz, you might have only, maybe a couple of feet in circumference. Perhaps you can get away, depending upon the application, with diameter rather than circumference. But in any case, it's very small compared to a wavelength, a very small fraction of a wavelength. And for that reason, invariably, you're going to have a radiation resistance, R sub R, that is very, very low. The fact that radiation resistance is so low means that the slightest loss in any component of the system, be it the antenna, the short length of line connecting the antenna to the tuning network, which is this combination of two things right here, a resonator, usually a capacitor, to tune the reactance out, leaving a very low, purely resistive impedance, step-up transformer to step it up to 50 ohms for the coax that goes to your radio. So here's your tuner. Oops. Well, I don't know. What are you going to do? Get rid of that? Okay. And the loop antenna also has a very low radiation resistance. So the slightest bit of loss anywhere in this system is going to have a highly adverse effect on the behavior of this circuit. And remember, radiation resistance is purely a function of the physical size of an antenna in space. There's nothing whatsoever you can do about it. At 14 megahertz, if your loop is 1 foot in diameter, it's going to have a very low radiation resistance, probably less than an ohm, and there's nothing whatsoever you can do about that. The only thing you can do is to minimize the loss resistance so that it is much lower, only a small fraction preferably, of the radiation resistance, and that can prove to be exceedingly difficult. But it has been done by using large diameter pipes for the loop. By large diameter, I mean maybe an inch, and soldered connections everywhere throughout, thoroughly soldered connections, large low loss capacitor here, probably a transformer here, a toroidal transformer most likely with heavy gauge wire, the toroidal so that it'll minimize the number of turns needed, and everything made sure that the connections are secure. Ideally, you'd immerse the whole assembly here in liquid helium to get it down to a degree or two absolute, but that is generally not practical for everyday hams. Maybe in a specialized physics labs it would be. Then you could get away with a loop that was only an inch in diameter and have superconductors for all of the wires and loops and capacitors and everything. But you can't do that in real life. So what you're stuck with is minimizing this loss. Now, one manufacturer that used to do that was called I believe it was AEA. They called their antenna the IsoLoop. I believe that MFJ Enterprises also makes one. But the construction is very critical. All the connections have to be sound and clean. And then you can, in fact, get reasonable performance out of a small loop like this. Once you've done that, then get on the air and go. I've often wondered how this would work for mobile applications, because being a balanced antenna, it doesn't really need a very good RF ground, and mobile installations just don't offer those in general, and with today's plastic body cars, they offer none. So what we have here is the basics of the functioning of a small transmitting loop antenna, courtesy of W1GV, Whiskey 1, good vibrations, di-da-da, di-da-da-da-da, da-da-dit-di-di-di-da, saying 73 for now, which means best regards in ham radio jargon, and so long. Di-di-di-da, di-da.